Okay, this is video number 3, and now we go into what is called requirements specification. So we have discovered some or all of our requirements, and we want to specify, we want to write them down. And of course, this can be in a tool. It doesn't have to be on paper or anything like that. But the question is essentially, what are the different ways of specifying, of writing, of expressing requirements? Now, the first thing to consider if we talk about specification is that a specification, a written down account of our requirements, can have a lot of different purposes. And it's important to consider what the appropriate purpose is, because depending on that purpose, you might want to use different ways of expressing your requirements. And maybe the most traditional, or the one that comes to mind first, is that we want to write down requirements so that our software developers can develop the system. They know what to do, essentially. And as you can imagine, here you might need some more technical details, or you might need some more breakdowns, so not just the high-level things that the user wants to do, but then break them down into smaller parts. And this might have to be on a rather technical level, depending on the system you develop. Now, another very common purpose for requirement specification is for contracting. So for signing a contract with a client, for example, you develop a system for the government or any ministry, and this is really your legal document that says what you have to deliver, in what time frame, and things like that. Again, as you can imagine, this might look very different from the development document, because maybe some of the technical detail you can skip, you don't need it for the contract, but you might have to add some other things. For example, more discussion on the priorities. You know, what priorities, what things are developed in a certain timeline, if you run over budget, what happens, or considerations like that. Now, you might have a requirement specification that is, in a way, explaining something. For example, some kind of technical user manual for end users or operators. And this is then slightly different from the development document, maybe, because it's more targeted towards the users. They might not need all the technical details that are hidden from a user, but they might need some other consideration, or they might need some easier language that is non-technical or is targeted towards a specific domain. So earlier I've talked about cars. So you need to have a technical user manual that is readable by regular people that drive. But for example, if you have a financial or a medical system, you might have a certain type of user with a specific expertise, and this document has to reflect that. For example, use the right terminology, but typically just hides some of the technical complexity that is not relevant to an end user or the target group that you're interested in. And finally, this is probably not an exhaustive list, but a lot of these specifications are there to document the system in any way. And this can overlap. So you can have a document that is for development, but it's also for documentation for the future. And this is really, really important, because most systems live for a longer time, and things might change, and your developers or the requirements engineers, they might leave. So it's a place to write down what you develop. And this can enable you, for example, in the future to make changes, that you understand what is it actually we developed, and why did we develop it in a certain way, why was it needed, and all those kind of aspects. So a lot of the systems are not just throwaway, we develop them, it's done, and the system maybe lives for a couple of months, but usually we develop systems that live for a longer time. This can go to quite extremes. So for instance, in railway systems, you have some regulations that say the software needs to be maintainable for 100 years. So you can imagine that the document that describes the system needs to be rather detailed, so that you could make changes in 80 years, for example. Now, keeping this all in mind, what options do we have to specify, to write down requirements? By far the most common one is to write requirements in natural language. So just regular sentences, and there tend to be some rules to make this slightly less problematic, because natural language is very open, is very ambiguous, has a lot of different meanings. And to avoid that we have lots of misunderstandings, we typically follow some rules. One of them is that we tend to use specific vocabulary. So a common thing is to use the so-called shell statements. The system shall do X, and this just describes what is it, what the system, a part of the system, a component. Shall, it's required, it has to do this, and then you describe an action. For example, a common anti-pattern, what you should not do, is to write should, because this sort of implies to the developers that it, is not really important. It should do this, but if it doesn't, it's not a problem. So it's almost a bit like legal language. It says this has to look like that. There are some other rules that we typically follow in this context. For example, we avoid conjunctions, we avoid and or. And the reason for that is that this means we put multiple requirements together. For example, if I say the system shall allow to use voice commands to enable the radio or navigation, the first question is, when is this fulfilled? Is the requirement already fulfilled if I can enable the radio but not the navigation? Do I need both of them, or is it up to me to decide? So this very quickly becomes ambiguous. So usually the literature says, if you have something like that, split it in multiple requirements, or make it very clear what this actually means. Is it optional to have either or what does the conjunction mean? Now, because natural language is very imprecise, there are some attempts to formalize this more, and one of them is to use so-called predefined structures or templates. And this means you have certain fixed sentences with placeholders where you should insert text. And it's a structured format that every requirement looks fairly similar. This is very common, for example, in embedded systems where you, for instance, have very often time behavior. You say, if a certain signal arrives, if a button has been pressed after X seconds, something should happen. So usually you have a couple of these sentence templates that you can use, and depending on your domain, they actually fit a lot of the requirements. And the good thing with that is that it's very easy to read. They don't all look different, but it's very standardized. There are also ways to directly translate that, for example, into test cases that we know how to test them later on. And we generally just avoid ambiguity and misunderstandings. The problem is, of course, they're more complicated. So you have to somehow get whatever you want into these templates. And now and then you will encounter situations where whatever you want to express doesn't fit any of these templates you have. And then maybe you need to write a regular sentence again. One very well known of these predefined structure that you probably have heard of are user stories. So that's a format that became popular with agile development. There are various different user story formats, but maybe the most well-known one is as a user or actor, I want to, followed by an action, so that, and then you have a reason or a rationale. So you insert who is the actor, and especially user is a bad term because you might have lots of different kinds of users. So who exactly needs to do this? What do they want to do? And why? What's the rationale? And the good thing with this is it's very brief. It's not very long. It's very clear who the stakeholder is, and that can be important if you need to better understand it. And it's also very clear why we need something. And this is very often an issue if you write down requirements and give them to developers, that they might see a statement, but they don't understand why it's needed. And this can lead to misunderstandings or different ways of implementing it. And especially in the future, if you want to change something, you might not anymore understand why you even had those requirements. And that can lead to removing things from the system that were actually really important. You just forgot why. So this is why this is a particularly popular format. The issue is, of course, everything has to be connected to a user. So it's a bit hard to express requirements that are maybe more technical and are not directly related to some user action. So this is more fitting for the user requirements that we discussed in the first video. There are a few more. I mentioned two more. One are so-called form-based requirements. This is usually something that you see in tools and it gets combined with other things. It just means that you add metadata to requirements. You have a form, like a registration form online, and maybe somewhere you can enter a natural language requirement or a predefined structure, but then you have additional things, for example, an ID, a priority. So you have different fields that you have to fill in. So this is very common when you just use electronic systems for writing down your requirements. And then finally, and I mentioned that in elicitation, we have scenarios. So we can write down different user flows. The user gets into the car, switches on the ignition, and so on. And again, similar to user stories, there are different ways of writing requirements. A very popular one is so-called use cases. Again, there exist different ways of writing them, but what is very common is that you have a main flow, the success case, what happens if everything goes as planned. As I just mentioned with the voice control, you can describe what happens. And the good thing is it gives you lots of detail. So for the engineers, it's again maybe easier to understand why things need to be there. And then you often have alternative flows. So what happens if something is wrong? For example, the user says something, the system doesn't recognize it. What happens? Should I ask again? Should I abort the action or things like that? So these are also very popular ways of writing down requirements. And depending on the document and the purpose, you typically combine a lot of them. So you might have a few user stories to give you the high-level ideas, what the user needs, but then you go into more detail on a technical level, or you give a lot of context with the scenarios so that the engineers can understand what's going on, but then you also have the detailed requirements that you can, for example, test very well. Finally, it's important to say that all of this is for functional requirements. So this is primarily on a functional level. In the second part of the video, that's the next one, then we talk more about how to specify quality requirements, which has different concerns. You might use similar techniques, but it's slightly different in how we express these. Another final note is that I have excluded graphical ways of writing requirements, for example, diagrams and models. These exist as well, but I'll cover them in a different part of the course.